Algebra 1, Unit 4, Lesson 2, Function Notation. For today's warm-up, we have each graph below represents the distance of a dog from a post as a function of time, since the dog owner left to purchase something from a store. So this is the same problem that we graphed yesterday for all of 3 days. We're going to use the given graphs to answer the questions below, and we're going to answer it for each of the 3 days, okay? So question A says, how far was the dog from the post at 60 seconds after the owner left? So for each day, we're going to go to 60 seconds. What's the distance? Day 1 is 4. Day 2 is also 4. Day 3, 60 seconds, here, 4. Part B says, how far was the dog from the post when the owner left? So where did the dog start? And each day, these 2 points, or this point is the same. So the dog starts at 1.5 for all 3 days, if you remember that from yesterday's lesson. And then C says, the owner returned after 160 seconds after he left. How far away was the dog from the post at this time? So we are looking at 160 seconds. Sorry, I'm color coding, hold on. So 160, that's the very end of our graph. You can't even see the number here, it got cut off, but that's okay. So day 1, we're just below 4, so 3.8, 3.9, something around there would be fine. Day 2, the end of our graph is at 4. Day 3, he stopped in between 0 and 1, so maybe 1.5. Oh, sorry, 0.5. 0 and 1, 0.5. Okay. Question D says, how many seconds passed before the dog reached the furthest point he could from the post? So for day 1, the furthest point that the dog reached is up here at 5, and that was around 50 seconds. Day 2, the furthest point is right here at 5 again, but at, 35 seconds. And day 3, he got to that furthest point rather quickly, so maybe 5 or 10 seconds would work for that one. Okay, consider the statement, the dog was 2 feet away from the post after 80 seconds. 2 feet away after 80 seconds. For which graph is the statement true? So let's just plot that point and see if it lands on the graph that they gave us. So 80 seconds, 2 feet away. Day 1. It's not that far off. It could work, right? Day 2, definitely not. Remember, the dog laid down, so definitely not day 2. Day 3, it actually lands on our graph, so let's go with day 3. Okay, so just a little warm up over interpreting graphs before we get into this new notation. So function notation is a way of writing inputs and outputs rather than using like a coordinate point. We can also talk about multiple functions at one time. So we actually give the function a name, and we just call the function f, g, h. You can really use any letter that you want, okay? And then we know that x represents our input, okay? So this notation here, f parenthesis x, represents the output of the function, okay? And the way you even say this is f of x. is how you say that notation. So function f is the name, the x is the input. Whatever f of x equals, this is your output. Okay, x is your input. So right now you're probably super confused, but the more you work with it, the easier or the more it kind of makes sense. So let's name the functions that relate to the dog's distance for all 3 days. So we are going to label day 1 as f. So day 1 is f of x. Day 2 is going to be labeled as g of x. And day 3 is going to be h of x. We're going to use function notation to fill in the table. So the distance is the output, okay, from the post at 60 seconds. So rather than writing all of these words, we can use function notation to show, okay, day 1 at 60 seconds, what's the distance? So day 1's function f, 60 seconds is your input. You would find this on your graph to get the distance. So day 2, similar, we named it as g. The input is still 60. So g of 60. Day 3, we labeled as h. The input is still 60. Okay? The distance, again, is output from the post when the owner left. So when the owner left, our input or our time is 0. So on day 1, or function f, what is the distance when time is 0? F of 0. Day 2, or function g, what is the distance when time is 0? G of 0. Day 3, or function h, what is the distance when time is 0? H of 0. Okay, let's try one more. The distance from the post, 150 seconds after the owner left. So 150 seconds is the input. Day 1 is function f. Input is 150. Day 2 is g. The input is 150. Day 3 is h. The input is 150. Okay, so let's try going the other way. If I give you the function notation, can you describe which expression and like what it represents in the context of this problem about the dog? Okay, so f of 15. The f means day 1, right? The 15 is your input. If you were to find this, that's your output, okay? So using our scenario, f of 15 represents, it equals the distance at 15 seconds on day 1. That was the f. That's how we labeled our function. Okay? The next one says g of 48. G was day 2. 48 is our input. If you were to find this on the graph, you would find the output, which is y. So again, the output is the distance at 48 seconds. What day are we talking about? Day 2, because it's labeled with the G. The last one here, we have H. T, so we're not really given a number, but T just represents time. If we were to solve this, we would be finding the distance, okay? So H of T represents the distance at t minutes, we don't know the actual number, they just gave you a variable, on day 3, because they used the letter H and we labeled day 3 as H. Okay. Let's try this again. So the equation g of 120 equals 4 can be interpreted to mean on day 2, so for function g, day 2, 120 seconds after the dog owner left, the dog was 4 feet from the post. We see our input, we see our output, g tells us which day. So what does each equation mean for the given situation? So we can phrase it the same way they did. We could phrase it the way I did up here. As long as you have all the information, the input, the output, and what day, that's fine, okay? So if we have function h, this is day 3. 40 seconds is our input. So 40 seconds after the dog owner left. The dog was 4.6 feet from the post. Okay, now I don't know about you, but I'm not gonna rewrite this every single time. So I'm gonna copy and paste and just change the numbers that I need to change for each problem. I'm also gonna change the color, okay? So for the next one, we have function f. So on day 1, t, so we don't know the actual number for time. So after t seconds, the dog owner left. The dog was 5 feet from the post. Okay, so we changed the day, we changed the seconds, we changed the distance. We have the day, the seconds, and the distance. Okay, so I'm going to paste another one in for the last one here. I'm going to change colors. So C, we have G of T equals D. So G means day 2. I don't have blue on here. How do I get my color? Whatever, I'll just use purple. So day 2, our time is T seconds, and our distance is D feet. We don't know the numbers for these. It's just in general. Okay, so we changed the day based off of the letter G. We changed our input to T. We changed our output to the letter D. Okay, so summary of function notation. The letter out front is just the name of the function. There's nothing else that you do with it, it's just the name. The input of the function is inside the parenthesis. What this whole function equals is the output, or the y value, okay? So let's do another activity here to practice this. So rule B takes a person's name as its input and gives their birthday as an output. Rule P takes a date as its input and gives a person with that birthday as an output. So complete the tables below with examples from the class. So since this is a video and I'm not in class with you right now, I'll just make up some. So this one, we have our input is the name. So this one must be rule B. So I'm just going to label this as B of X. Okay, so I know which function this one is. The second table has the input with the date, so that's rule P. Okay. So let's use me. Let's use Mrs. Biller. And my birthday is on March 13th. If I filled out this table, then I would say March 13th is the input, and we would have Mrs. Biller as the output. Okay, let's just come up with a name. So let's say Sarah is the name, and her birthday is August 5th. So if you write it the other way, August 5th is the input, and Sarah is the output. Okay, we'll do one more here. Let's say that, I don't know. Let's say Ahmed has a birthday of February 12th, just like Abraham Lincoln. If we do this table, we've got February 12th is Ahmed. Okay, so if you use your name as the input, how many outputs are possible? So how many birthdays can a person have? There is only one possible output. So that means this is a function. Each person has one birthday. If you use the birthday as the input, so function P, how many outputs are possible? So if you have a birth date, are you guaranteed to only have one person with that birth date, or could you have multiple? We could have multiple outputs. More than one person can have the same birthday. So that means this is not a function. So only one of the two relationships is a function, the other is not. Which one is it? B of X. Or from question 2, the name to a birthday, right? For the relationship that is a function, write two input-output pairs from the table using function notation. Okay, so using our first table, we have function B of, and then let's use my name, Mrs. Biller. And my output or my birthday is March 13th. And we could use the other one. We could do Abraham Lincoln because everyone will have that one. Abraham. And his birthday was February 12th. Or that was his output. So again, the input goes inside the parenthesis. The output is what that function notation equals. Okay, so continue practicing writing and interpreting the function notation with the check your understanding here. Question 1 is write the expression or the equation that represents this situation. So just describe the function notation, okay? And then question 2, you're going to go the other way around. So given a description, can you write the function notation? Let me know if you have any questions.